Elementary statistics, looking at section 8.5. So in section 8.5 we talk about testing a claim about a standard deviation or variance. So we've been testing and doing hypothesis testing on proportions and means. Basically, how can we take a sample and relate it to an entire population. Now we'll look at about that standard deviation and variance. So as we look over on our table over here, they give us some piece of information that we'll be using. So basically we'll be conducting a hypothesis test about a claim about a population standard deviation sigma, or that population variance sigma squared. A couple things we'll need to know is our sample size. We'll look at our sample standard deviation or our sample variance, and then we'll see what we're testing towards, either our claimed variance or our claimed standard deviation. Okay, once again, the requirements: the sample is a simple random sample, and the population has a normal distribution. Okay, so please remember, instead of being a loose requirement, okay, this test has a fairly strict requirement for normal distribution. So we have to make sure that our population is from a normal distribution, not just approximately normal. What we'll be looking at is we'll be looking at the test statistic in here. Chi-squared equals n minus 1 s times our standard deviation squared divided by our sigma squared, round to 3 decimal places. One of the notes in here, once again, we could use our p-value or our critical values. If you notice, I have it written there. We cannot do, because we don't have the built-in software and features that our TI-83 or 84 plus calculator would have. We could try, sometimes we could finagle some things in there, but our TI-Nspire calculators are a little bit, our TI-Nspire CX calculators are a little bit limited here. Okay, now please remember, caution, the chi-squared test in this section is not robust, okay, against departure from normality, meaning that the test does not work well if the population has a distribution that is far from normal. Okay, so the condition of normal distribution population is therefore a much stricter requirement when testing claims about sigma or sigma squared, once again a population standard deviation or population variance, than tests of claims about a population mean, which was in our previous section. So basically what we're going to be looking at here is a couple steps as we go through. We'll be finding all values of chi-squared are non-negative and the distribution is not symmetric. There is a different chi-squared distribution for each number of degree of freedom. The critical values are found in our table A4, once again using degree of freedom, n equals 1. Okay, so if we're using this table, basically each critical value of chi-squared in the body of the table corresponds to an area given in the top row of the table, and each area in that top row is cumulative area to the right of the critical values. So once again, as we look at, this is our normal chi-squared table. As our degrees of freedom get higher or grow, or we have larger numbers in our sample, we get closer to that normal distribution. So some of the things to be careful with in here is a simple fact, once again, that as we start looking in here, we got to distinguish whether we're to the right or to the left. So remember, our middle here is not going to be equal on each part. So we're actually going to have different distances as we look at the lower half or the upper half. So as we're testing claims being less than, or if it's greater than, this area might look bigger than what this is, or it might have a larger distance, once again because of the skewness of this graph. Okay, so just something to be careful with as we continue through this entire scenario.